The
This
reason
conference will now be recorded.
the reason is as the pump, like the pump circulates that water, there's water to the top, already at the top, so that water's helping to push itself back down and helping the other side push back up. So it's really kind of, you know, self-sustaining each other. It's doesn't, when you turn it off, it's still, the pipe is still filled and everything like that. So you don't have to really worry about the static height of a building when determining pump head on a closed loop system. Conversely, you know, the NPSHR, the acronym is net positive suction head required. It's normally not a factor because every pump, you know, needs a certain amount of pressure for it to operate correctly. So you don't cavitate the pump so that you know, it sounds pretty good. You're not causing issues with the pump. In fact, if you don't have enough, the acronym stands for not pumping so hot, because the pump sounds terrible. It sounds like you're pumping rocks through it. When actually what's happening is there's like little bubbles inside of the impeller. They're kind of imploding onto the impeller. I got a picture later that shows what a impeller looks like when it's had cavitation, but essentially looks like someone hit it with a ball peen hammer, and it's got these little dots all over it. And it can eventually whittle the impeller away to almost nothing. So, but in a closed system, since the PRV sets the system pressure, and then the expansion tank or compression tank keeps and maintains that system pressure, there's usually enough pressure at the pump suction that you don't have to worry about the net positive suction head. Since the water never leaves the system, the exit losses aren't an issue with pumping a closed loop system. On open loops, you still have to worry about the pressure drop through the equipment, friction loss. But now, since there's a break in there, and the pump does have to overcome that break, you do have to worry about the static height or some type of static height, because that water, if it turns off, it's going to seek a certain level, and that pump then has to push that water to the top. So you do have to make sure the pump is going to be big enough to get it up to the height of the top of the system. The net positive suction head is going to be a factor. I've seen a lot of like cooling tower applications where the pump is, you know, 2 or 3 feet below the pan. You know, sometimes it's the way it has to be, unfortunately. But if you're designing a new system, you want to make sure whatever the suction requirements of the pump, you do want to make sure you try to maintain that, or you pick a pump that has a lower suction head requirement. And then exit losses are important because it does leave the system at some point, whether it be, you know, in a pressure boosting application, whether it's through the faucets, or in a cooling tower where, you know, you got to worry about the spray nozzles. You know, some of those will have like a 10-pound drop across them. So you do have to be careful with that and make sure you have enough. So the way they go through an actual calculation for the pump head in a closed system. So basically they follow the one loop. You don't actually add every single pipe loop on it. You just want to pick the one that has the longest or the highest pressure drop through that loop. Generally speaking, it is the one with the longest pipe run, just because, you know, that loop is the longest, and therefore it's trying to shove so much water through that pipe. So they add up all these little equivalent feet of pipe length, and you got elbows in there and valves, and every one of those has, you know, where the pipe is 1, the valve might be 3, the elbow could be 4 or 5, and that's dependent upon, you know, what different type of elbow you're using. But they basically add all this stuff up. Then you got to apply a friction loss factor, and that is dependent upon how much GPM is trying to go through the pipe that you're using, the pipe diameter that you're using. They use, I'm sure there's programs out there. I use B&G's system sizer wheel that they have available. There's also a download for it that you can get on your tablet or smartphone in whatever, you know, Android store or iTunes or what have you. But basically, you tell, like, I got 3-inch pipe. I'm trying to put, you know, 50 GPM through it, and it'll tell you what the friction loss factor is. So you'd actually apply that to that equivalent pipe length that you came up with. After that's all been added, you want a safety factor applied to the whole foot of drop that you need to overcome. The safety factor, typically on smaller systems, you're going to use a larger one just because it still doesn't affect it too much. Some of the smaller systems only have like 15 or 20 foot, pressure drop in it, so to put 50% on top of it isn't really that much. You're not really adding that much. But in some of the larger systems where you got 50, 60, maybe even 80 foot of pressure drop that you're trying to overcome, a 10% or 15% is really plenty, because it obviously changes it quite a bit. So the pump head that they figure out for the open systems is very similar. You're still going to have to go through your equipment losses, your length of pipe that you're going to have, but then you got to add these exit losses that you're going to have, as well as this, whatever height that you need to overcome. So those two have to be put in. Then sometimes it could be quite substantial to put those in. So you do want to, and I've seen pumps not work because somebody forgot to put in the height of the system, 10 feet. It could certainly cause a pump not to circulate water. So just a rule of thumb sizing. A lot of times you get out there and you just need to have something to kind of go off of. Basically, it's that boiler rating divided by 10,000, or if you're doing cooling, chiller, cooling tower, tonnage, multiply that by 3 to get your GPM. And then for the pump head, I try to figure out like the longest loop. So you're kind of thinking, well, the pump, it's about 100 feet that way. It's going up 30 feet. And it's coming back down 30 feet, and it's coming 100 feet back. But you kind of estimate what that longest loop might be, multiply by 1.5, and that usually gives you a good rough estimate as far as a safety factor, as well as adding more pressure drop, because valves and T-fittings and elbows and everything like that do all add more pressure drop to the system. So that gets added in that extra 50%. And then you multiply by a friction loss factor. 0.04 is what I typically use. It is on the very high end of the scale. So there's a lot of extra safety kind of built into it, so that you don't really underestimate the head when you're trying to just kind of guess on what it is. But 0.04, like I said, it's on the high end. You could get it a little bit higher if you're trying to flow more water through a piece of pipe, but there's usually a range you want to try to maintain. And that, like I said, that 0.04 is right there at the top end. For open systems, I try to add the height of the exit into the entrance of the system. For towers, a lot of times that's just 10 feet that I add to it. And then any exit losses, again, we're just estimating here. So a lot of times, if it's a tower, I'll add like 5 to 10 pounds. If it's a pressure booster, some of those get to be like 20 to 40 pounds now, with some of those lower flow fittings and shower heads and faucets and what have you. Some of the other things that pumps are used on, other than just plain hydronic type systems, are condensate transfer systems, whether you got just a condensate pump itself or more of a boiler feed unit. They're size fairly similar in that you're doing 2 times the return rate, but it's where that return rate comes from. So condensate units are usually sized on 2 times whatever is getting dumped into that condensate unit. That way you got enough pump flow to get the water out before it overflows or anything like that. Boiler feed units, it's the boiler evaporation rate. So you want to make sure the pump can put in twice the amount of water into the boiler that it requires. That way, you're not going to put it in a low water condition or anything like that. The pump header, again, it's fairly similar. It just really depends. It's very similar as far as you you figure it up. So you got pipe lengths and everything like that. Once you get this, you do have to worry about elevation changes. Like for condensate pumps, a lot of times that's going into a deaerator. So you got to overcome whatever the deaerator pressure is. But after you figure out the pipe loss, you do want to add, depending on whatever that discharge pressure on the condensate pump is. If it's under 50, you want to add 5 pounds to it just for a little safety factor. If it's above 50, you want to add 10. Boiler feed, it's a little bit different because you're going into a boiler, and that boiler could be, 100 pounds or 75 or 10. So you got to make sure that you're overcoming that. So you want to be at least 5 pounds above the boiler working pressure if it's 50 pounds, or 10 pounds if it's above 50. Otherwise, the water just won't go in there. So you got to worry about your friction loss as well as your boiler pressure for boiler feed units. The tank size that's on these, kind of maybe cut off on the bottom there a little bit, but for the condensate, basically those pumps are designed to run for 1 minute. You want to get the condensate out of there as quick as possible. You don't want to let it cool down or anything like that, so you're not reheating it back up at in your boiler feed unit or your deaerator. So it's not really going to stay there too long. The boiler feed pumps, they want to have about a 10-minute storage on that, so the tank is going to be a lot larger. The reason it's so large is that you could get like slugs of water coming back, and you don't want to certainly overfill it because it's all treated water usually at that point, or treated condensate, or it's heated up already. So you want to be able to store some of that as it comes back, because it just varies so much depending on what each little area is doing. Another system is domestic hot water recirc pumps. A little bit different on this. So the way the pump flow is set, it's basically a heat drop in the piping. A lot of them are insulated, but there is going to be some heat loss in it. Typically, the way they design these are about a 10-degree delta T. So if you're sending out 140, usually comes back at 130. There's charts to depend on how well insulated the pipe is and how much. You can go certainly less. Obviously, you'll need more GPM, but whatever that chart kind of dictates how much, whatever it says, it kind of dictates how much flow is going to go through. The pump head, you just have to really worry about the friction loss in the return pipeline. The reason for that is the supply line, might be 2-inch, and you're only bringing 1 GPM through, and the friction loss on 1 GPM in 2-inch pipe, it's very, very negligible. The friction loss factor is like 0.0001. It's so low that the safety factor is going to just a little portion of that will get it through the supply line. So you just have to worry about that length of that return line and whatever that is, and they would figure up the friction loss through it. Rule of thumb, a lot of times the recirculating line is only, like I said, 3/4 to 1.5 GPM per line. So if you'd have a system, it'd have like 4 or 5 different lines. You'd multiply. I would typically go with 1. So I need a pump that would do 4 to 5 GPM. And whatever the longest return line would be, you'd take that times 1.5 times the 0.04. Domestic water pressure boosters seems to be quite prevalent lately. Last several years, as people get further and further away from water towers, or when developments get larger and larger, and everyone seems to need more and more pressure. It also doesn't help that a lot of these low flow fixtures require like 40 pounds for them. Like I've heard some flush valves just require 40 pounds for them just to work. So a lot of places are needing some type of pressure booster. So the pump flow on these is kind of determined by the type of fixture and how many of those are in there. Like a toilet requires something a little different than a shower, and that requires different than a lav. Then you got to worry about like laundry if you have a laundry facility on site, the type of building that it's being occupied. So a different, like a dormitory requires different flow requirements than just a commercial building. But every one of these has a little different fixture value for these different fixtures. And then there's just one chart that, depending on if you have flush valve or tank valves, for this fixture unit, and it would tell you like, oh, you need 100 GPM or you need 50 GPM off those these charts. Pump head, it's really, most of it's going to be your elevation change. You do have to worry about some of that friction loss in the pipe, but a lot of it's going to be elevation change and any exit losses through these like flush valves and everything. So first thing I would always ask is, where's that backflow preventer? A lot of times those are somewhere between the 10 and 20 pound drop across them. So if it's before, and someone might say, well, I got 40 pounds coming in, I need 80 going out, and that's fine. But if that backflow is before the package, well, you don't exactly have 40 pounds coming in, it's lower. So you may have to worry about how low that pressure that pump can go down to. There's some of these I've seen where they put the backflow on the before the pump, and it chewed up all the pressure coming into the pump. So there was only like 5 or 10 pounds of pressure to the pump. So you do have to be careful where that is at for proper pump operation. But you're going to need to add up any pressure drop that you see with like the backflow, your elevation change, and then your exit losses for that. Like I said, some of those flush valves can get up to 40 pounds. So you need to be careful with it. The other thing you want to have is an expansion tank on these. They add like just a little buffer tank. It's probably been 10 years since I've sold a constant speed pressure booster. So I think most people use a VFD driven one. So this 10 to 25% capacity of the largest pump. So that's where the pump would actually go out on the curve. So your pump might be designed to handle 50 GPM, or that's what your system would require, but the pump can go out to like 75. So it's at 75 that we're looking at, and go to 10 to 25% of that. So most of the time you're looking at somewhere between a 7 to 20 gallon tank. So they're really fairly small. Like I said, it's just there for a buffer as you get some of these flush valves or solenoid valves that are closing, so that water has somewhere to go. So this is question number 2 that we're going to have here. So what is the pump flow required for a 1.5 million BTU system with 20 degrees delta T? So we got the math up here that we saw in the equation. And the answer is 150 GPM.
Okay, guys, that's your second question. Make a note of that. What pump flow is required for a 1.5 million BTU system using 20 degrees delta T GPM on blah, 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 blah. The answer is 150 GPM. You're going to have to type it in, guys. 150 GPM. Back to you, boss.
So we could actually take the break now if you guys want to, or.
All right, it's a little early, but let's go ahead and do it. We're gonna take a 15-minute break, guys. We'll see you in, I got 5:07 on my clock, so we'll see you in 15 minutes. That's 5:22. All right? Okay, guys, we are back, and I'm going to make Eric the presenter again here. Should be passing it over. We are running a little fast, so we're probably going to be out of here well before 6:30. But the biggest part of it's coming. But just wanted you to know. All right, back to you, Eric. It's all yours. Thank you.
All right, we'll go to the get to the part where really look at the pumps, and but first I got a little there it is, a little video here. B&G put together a few years ago. It's really part of their program that they're doing now, where they're using, everyone's really going after the efficiency, and it's called their Power of E, and there's all kinds of things with this Power of E, and it's a lot of their, their history, that what they've done as far as, always having good, reliable pumps, the training that they have done, the product advancement that they've had. A lot of the stuff that with this Power of E here, so it's, efficiency, it's enhanced features, it's new features, it's involves even like training and everything like that they've done over the years. But it's a nice little video they kind of put together, highlighting some of the new the pumps and that they come out with in the last 5 or 6 years, and changes that they have made to show that we're doing that. They're really trying to put out efficient products and trying to educate the industry. I don't know how many if any of you guys have gone to the Red Schoolhouse. It's an excellent place to learn a little bit about pumps and systems, and a little more in depth than what we're doing here. But hopefully I'll get those started back up after the whole pandemic and everything ends. But really good class, a lot of good classes if you guys haven't gone to those up in Chicago. So we were talking about before is coming up with the GPM and the feet ahead with the pumps and sizing them and how they were sized. It's tough to get to that point sometimes, but once that's all determined, now you got to actually pick the pumps that you want to do or want to use. I'm going to go over a couple of the different styles of pumps first. You got your inline pumps here. As you can see, they're smaller pumps typically, like this pump here in the middle here. This one can get up to larger flows and higher working pressures. But you can see a lot of these here, a lot of your little circulator pumps or runaround pumps. Even these here that you got these vertical multi-stage pumps. A lot of times these are only putting out 5 GPM, 10 GPM. They are used on pressure boosters where you can get out to 50 or 60. But for the most part, when you're thinking about 50, it sounds like maybe a lot, but some of the larger pumps can pump out thousands and thousands of GPM. So 50 to even 100 is a fairly low flow. They're also called pipe mounted pumps, and because they are mounted right in the pipe. Do you want to point out though, like especially this one here, as well as these they will be also mounted on the floor because they can get quite large. But for the most part, the pipe is supporting the pump itself. And as you can see, inline, the flow's in the same plane. It comes in one side, out the other. But usually used on smaller systems or smaller types of systems. Another is an end suction type pump. These are a little bit bigger. The reason they're called end suction is because the water it comes in on the end of it and exits out the top. They're generally mounted on the floor. They should be. I've seen where they're mounted in the ceiling. It's not really recommended. Get a lot of vibration usually, but I've seen them where they're mounted on unistrut up in the ceiling. hanging off, the pipe somewhere where there's mounting. It becomes very difficult to make sure they're all in line, and also to reduce the vibration that these things would have. But generally speaking, they're mounted on the floor. Actually ran into an application yesterday on these pumps, or actually years ago. Well, yesterday I ran into an application with these end suction pumps, and it reminded me of one that happened, a long time ago. That you should use cap screws on these types of on these pumps, especially the motor mounted ones, so we can get the pump out of there, so you can replace the seal. The installation on the one that I got reminded of, they actually used threaded rod, and you couldn't actually get the pump out if the thread rod didn't come out, and it was so long that it hit the motor. We had to eventually just keep cutting it out as we pulled it out. So it was kind of difficult to do that, but you should use some type of cap screws on these. Obviously these here where you got your own little base, or even this one here, threaded rod will certainly work there. But another type is closed coupled. As you can see, there's no bearing assembly or anything like that. The motor, the impeller is connected directly right onto the motor. A lot of times these are used really just for space saving constraints. These things, I think, they're a little bit harder to work on, because not only do you got the motor there, but you got the impeller hanging off of it. You got a motor bracket. And like some of these pumps here, where this motor bracket becomes pretty darn large, and this wheel becomes 9.5 inches, it becomes takes a lot of energy, maybe even a crane to pull them out, to repair them. So it could be a little bit more difficult to do so. So I only kind of recommend it if you really have a space constraint that you need to pull them out. These with the end suction, they're a little bit harder to kind of to pull out too, especially if this isn't piped in right. You want to make sure that there's no pipe strain. There's been a lot of jobs where I've gone out and pulled this out, and the whole volute will actually move because it's kind of put in a bind. It tears up bearings and seals and makes the pump noisy. In the worst case, I've seen where the volute's actually cracked on these pumps. But that's where these are usually used. It's almost always space constraint. And you got your base mounted pumps. The reason they're called that is because there's a nice fabricated base underneath that pump. They're also called flexible couple pumps because most of them have some type of flexible coupling in there. One big thing I do want to point out with these flexible couplers, most of them use some type of coupler that's good with the VFD. There are some out there that even B&G uses, like on their larger horizontal split case. Some of them have the Hytral coupler. It's an orange sleeve. It's very hard. The tolerances on those are really tight, and they're just not made to use with VFD. They tend to wear out really quickly. So you do want to make sure if you have a VFD driven pump that you're using the right coupler on them. Most of the ones that we use are either like a Woods Duraflex, which is the typical black spider looking thing. It's an EPDM coupler, or the Sureflex, and it's got the little bubble on it. Both those are, acceptable for VFD duty. I've seen plenty of those where, they're used in the orange sleeve and it just chews them up, and the spine, the little like spider thing sticking out, they get really pointy and everything like that. So you just want to make sure you get the right one using it on. These here, since they're mounted on a base and they're mounted on the floor, you can get, pretty easily get 250 pound working pressure. Some of the larger ones you can get up to like 400 pounds. So they're made for high-rise type buildings, or applications where you got much larger pressures. I find these to be a lot easier to work on. Generally, you don't have to move the motor to repair the pump. Even these, the coupler drops out, and then there's enough space to pull the bearing assembly out of the volute, so you can go ahead and make repairs to it. So that's one thing I like to work why I like to work on them. The components are also a lot lighter. You know, especially with these, you're just pulling out a bearing in this, or the seal kit, a lot lighter than pulling the whole motor out just to change a kit, seal kit. Even this here, where those bearing assemblies do get quite large, you know, you can usually still kind of muscle them out of there and to make the repairs that you need to make. The vibration is usually a lot less with this fabricated base. You know, especially when you get grounding in there, it adds all this extra mass and rigidity to that base. The vibration tendencies with base mounted pumps are a lot less. And you know, according to the Department of Energy data, base mounted pumps also last quite a bit longer than inline pumps or closed couple pumps. They just can handle the wear and tear better than those types of pumps. So they can usually last, I think it's like almost, it's like another 10 to 15 years, I believe, longer than like even a vertical inline pump that's kind of separately coupled. After they kind of pick the type of pump they want, the pump construction becomes important. You got listed out here iron body. Those are typically most of the heating and cooling applications. Some of the process applications you can use those on, as long as it's whatever fluid you're pumping is not attacking, you know, the cast iron. Then you got all bronze is another material that we use. Those almost exclusively used on hot water recirc loops. If you use a cast iron pump on a hot water recirc loop, eventually the inside of that's going to kind of rust, and you get these little like rust barrels. You know, kind of think of like when you see a boat sunk in the ocean, you have all this little rust, you know, things hanging off of like the railings of the boats and all that kind of stuff. That happens in the inside of the pump, this one here, because that water is highly oxygenated, and it will go ahead and start to attack the pump itself, the pump body, if it's cast iron. Eventually, there will get enough rust inside of there that on these smaller pumps, it will lock them up to where they won't run. Remember years ago, someone kept trying to warranty the pump, and it was like, this thing's a piece of crap because it goes out about every 9 months, and after the second one, I was like, what's going on? Because we usually don't have problems out of this type of pump. And he's like, well, you know, what kind of system? He's like, well, it's a hot water recirc loop. And it's like, well, that's not a warranty application. You should have a bronze pump. Here's the right pump. And, you know, they never had a problem after that. So you definitely don't want to use, I see quite a bit of iron body pumps on hot water recirc loops. So you want to make sure they are using bronze on those. A lot more expensive, in some case double the price of the pump, but it's sure in heck going to last a lot longer. The other material that they're using for hot water recirc loops now are stainless steel body pumps. As the price and stainless steel has come down, and it's a lot easier to kind of to use the stainless steel and everything as far as casting it. It's become more prevalent to use it. The other thing that we see them on is pressure boosters. A lot of people like to use the stainless steel on there. We used to use a lot of the cast iron pumps, and some of the still use like a coated cast iron body on it. On pressure boosters, the reason you used to be able to, or the reason you can use that is that in that application, the water is cold and it doesn't necessarily attack the cast iron body, but it actually gives it a coating. Since it's cold water, if it were hot water, it would certainly have a lot of problems, but with using iron body, but people have kind of gotten away from that. They don't want the cast iron body, so they've gone to stainless steel type fitted pumps or stainless steel pumps. You can also use the stainless steel pumps on a lot of process type applications, so you can use those there. And you know, then the other main thing that you have to look out for as far as that they kind of go with as far as pump types. A lot of the bigger pumps, they can get different seals in there. The Buena-carbon ceramic is kind of the standard that works almost all applications. You get to some of the glycol applications, and you need a little bit better seal with it. Some of the obviously high pressure applications, you need a much stronger seal than what that can provide. So some of the pumps that are picked also are dictated by what that seal needs to be. So, you know, some of the pumps where you can use it on a small pump, oh, I need a better seal. So you'd have to maybe go to a larger pump to use that type of seal. Have you gone through the pump, picking the right pump? You go to pick some of the pump accessories. Some of those, you know, suction diffusers, the balance valves or triple duty valves, which are very, very similar, except for a little bit added application on the triple duty valve, flex connectors, and there's, you know, just a variety of other things that can go with a pump or make pump installations a little bit easier, and I'll touch on some of those. First one here is the suction diffuser. It was almost used on a lot of, you know, end suction pumps out there. Very few times do I not see one on it, on an end suction pump. But basically this thing's job is just to provide a good flow condition into the end of the pump. If you don't have that good flow condition, you end up having stressing out the bearings, the seals, and basically you end up pushing on one side of the impeller as that water comes in. As more water is trying to go into a certain area of the impeller, so it ends up actually trying to, like, the impeller's up there and it'll try to wobble the impeller as the water's kind of hitting it up here. It's going to try to push it a little bit more. So the standard is to have 5 times the straight pipe diameter of uninterrupted pipe going into the end of the pump. Well, you know, on 3/4 inch pipe or 1 inch pipe, that's not a big deal. I mean, you're only talking, you know, 5 inches. On some of these pumps where it's 10 inch or 8 inch, you're looking at a much larger length. What the suction diffuser does, you can see this little crosshatch right in here. There's a straightening vane in there, and it kind of evens out that flow as it hits it. There's also an orifice cylinder inside, so it spreads it all the way around that the straightening vanes, and it gives you that flow condition going into the pump. So it just adds length, longevity to the pump, and allows it to work, you know, a lot less work and a lot less stress on the pump. I do want to point out there's a disposable startup strainer that comes in these. It's a fine mesh strainer. It's in there to get some of the fine particulate out of the system. So, you know, you run the system a little bit, you're careful on opening up the back of that because there is a rubber O-ring. You pull it open too quickly or too hard, you can actually stretch the O-ring and it won't go back into its seat. But you should be able to reuse it if you carefully pull that off, pull the cylinder out, and then pull that startup strainer. It's just a little brass strainer material. Pull it out. A lot of people, you know, hang them up, say, hey, I did take it out, make sure I took it out, but it just, in the end, gets thrown away. If it's an older system, you know, there still could be a lot of crap in there, a lot of junk, and maybe, you know, monitor that, and somebody, you go back and you know, pull it out and see what's in there. But certainly on newer systems, you can get a lot of junk that it collects, so it doesn't go into the pump and damage the seals or damage you know, other components of the system. You can also use on some of the double suction pumps. There are certain applications you need to use it on there. If the water is coming in, basically in a certain, I think it's, I'm sorry, it's the water is coming in parallel with the pump shaft. You can have a lot of problems if you don't use a suction diffuser. Most of the time the water is coming from the top. You got enough straight flow coming in that you may or may not need one. But people do still use them just because it's such a small compact elbow versus like a long radius elbow that you would have to use. A lot of people still use them on those where you got the side suction to the pump, and just to kind of make the installation look pretty clean. Some of the things that you might have on the outlet of the pump are balance valves. Basically, it just adds pressure drop to the system or to the pump. You're able to basically turn this dial down just to kind of add pressure to the pump to move it around on the curve. And I'll touch a little bit later on what that kind of looks like as far as the curve to make sure you get the right flow out of the pump. There's a couple different varieties here. These two are just a standard circuit setter. It's been around for a number of years. Basically, in these here, there's a ball valve that you turn the dial and it opens and closes. And depending on what the pressure drop across this is and how open or closed this valve is, you can actually read the GPM going across the valve, which is why they're, a little bit more than just a ball valve. This one here is kind of a step up. This is an automatic manual type balance valve. It's our flow setter. Basically, this dial up here has a GPM reading on it where you can go in there and set, I want 1 GPM or 2 GPM, and then whatever the flow, whatever pressure coming into this will not change that flow. It will always just maintain 1 or 2 GPM, whatever you have it set for up here. But it is adjustable, so there is a range on each one of these valves. This one down here has a flow cartridge, or ours is called a circuit century, but it's an automatic, or people call them automatic balance valves or flow limiter valves. Basically, there's a cartridge in here that no matter what the pressure difference across the valve is, there is usually a range that these operate in, but it's going to allow no more than a certain amount of GPM through it. This cartridge is set for, say 20. It will allow no more than 20 in, regardless of what's happening. It could certainly allow less, but it's not going to allow any more. So it's limiting the flow going through this valve. This is not adjustable. A lot of people like these in a variety of systems, because you cannot go in there and someone says, my little area is too cold, so I'm going to go open this valve up. No wonder, if you had a circuit setter, oh, no wonder it's only 20% open, and they don't realize that when you open this up, you might get a little more heat, but now somebody is losing heat, and you can have bigger system-wide issues. But with this valve, it cannot be adjusted. So, no matter what they try to do, it just isn't going to give you any more flow. You can certainly do less flow. But you can certainly come in here and change the cartridge out to change it to a different flow that you need, but it's just not easily done as what you have with the dial. The valve that's kind of similar to this is the triple duty valve. These are the ones that you really see on some of the larger pumps. It gives you that balance as well as a non-slam check valve, so that the valve inside this body is just a disc in here. When the pump turns off, the disc falls down, stopping the flow going through there. A lot of people like to use them because you don't have to install a shutoff valve, a balance valve, and a check valve. It's just one valve, so it's a nice compact design that you can have on here. I know a lot of people on these systems these days that don't want to put balance valves or triple duty valves in, and you're running the pump off of VFD. And that's okay. It's not typically a problem. However, if the head was overestimated and that pump starts to run on the end of the curve, and where it's falling off the curve, the VFD is not going to sit there and magically pull it back onto the curve. You actually have to add some type of pressure drop to the system. So on some of these like retrofits where they're pulling these out, you can find out, well, I'm off the curve. I got to slow it all the way down to where I'm not providing heat, but the pump sounds good. But if they had like a triple duty valve or a balance valve, they can actually close this down on this stem and add the pressure drop so they can get back on the curve. And I'll highlight a little bit of that a little bit when I'm talking about the variable speed curves and what have you in a little bit. There's also an angle version of this that you can use as an elbow as well. Flex connectors is another item that we see on the pumps quite a bit. The big thing that I like to see these on there for is just it alleviates a lot of the pipe strain that might be on a pump. Like I said, I've seen a lot of pumps where the pipe is coming in and there's no support or virtually no support, or it's kind of jammed in there, and eventually the volute will crack, and it cracks around the casing of the pump, It's a pretty common thing. Like it's really like if it cracks here, was probably where it was pipe stressed. It's usually either on the close to the discharge where it joins up in the volute, or if it's on the end of it, it actually cracks around the volute. And we see that every once in a while. And it's like I said, it's just stress on the pipe transmitted to the pump. Flex connectors will help alleviate some of that. You know, a lot of these are just like minimal offsets to 3/4 inch. But you know, you usually don't need a huge amount unless they're, you know, in a retrofit and you're trying to get it in there, get it worked in there. But it'll also give you some expansion capabilities so that it can sit there and shrink down as the pipe expands a little bit. The two types are the stainless steel braided corrugated hose. You can kind of see it a little bit inside of there, or the rubber style. You know, one versus the other, I really don't have an opinion, I guess, on one or the other. This tends to dampen some noise a little bit better than the metal does. I think the rubber does. But one way or the other, it doesn't matter too much which one you are using. I do want to point out, you can see this one here has like some cables that are already installed. But if the pipe isn't anchored properly, these will, and you're not using control rods on these things will actually pull apart to the point where this little rubber ring will pull out of the flange, and of course that would create a big mess. So I do want to make sure, you know, you want to use these control rods, or like these are like this control wire, so that these actually do not pull apart in the system. Or you want to make sure that the pipe is anchored properly, you know, at the elbow, and so it doesn't actually, the pipe will jump. There was quite a bit. There was a job I was on, and it was some cooling tower pumps, and I think that pipe, when the pump turned on, jumped up like a couple, it seemed like a couple inches, but it was extremely noticeable. You know, it was a 10-12 inch pipe, and I was a little scared to see that thing kind of jump up there. But I do want to caution you when using these. The braiding here restricts it from pulling apart too far. So this is what the braiding here is, what is really your control rod, or this little braided wire. Some of the other accessories, of course, you know, you see a lot of VFDs out there on these systems. This is a little control panel for the pump that you can have. You know, a lot of these, like especially retrofits or sensorless technology, kind of comes in with pumps. You know, you see a lot of the sensorless come in with retrofits because they don't have a system there, and they want to be able to have a way to control the pump. You know, some of this will take care of that. There's a lot of built-in capabilities on drives now these days where you don't need a control panel. It just is all done by the drive. You got, you know, pressure gauges, of course. Always good to have those so you can troubleshoot the pump. We got little flange isolation flanges. Excuse me. These are great for these small little booster pumps. A lot of times we go out there and don't even see, you know, shut off flanges around the pump, and inevitably that's the one that has something wrong with it, or you know, the pump's not working properly, and you got to drain the whole system. You know, where if you have these, you know, you're looking at just a little small amount of water that you lose. Most of the flanges are built in, so it makes it pretty easy to install the pump as well. And then these couple things down here, you got like aquastats and timer kits, and those are usually for hot water recirculation loops. As some of these pumps get a little bit smarter, you're going to see you can even tie in like differential pressure sensors right to pumps, or temperature sensors right to pumps. So there's even more pump accessories that you can get on these things that I don't show here. So I'll go through a quick pump installation here. This one doesn't look too bad at all, but we'll start from getting this thing on a nice level concrete pad. a good base is helps to ensure that the pump isn't going to vibrate, that's going to be installed properly, that you're not going to have issues down the road that you could have fixed with having a good starting point with a good level concrete pad. And we'll start from the suction side. So you got your shutoff valve here coming in. You got a little flex connector here. This one's a fairly small one here. We're going to come into the suction diffuser for this end suction pump here. And then we got a support foot. This is really important to have this on here. It doesn't seem like it's much because it's just basically a piece of pipe with a a bolt that kind of pushes up and down on this pipe to give it additional support. But if the pipe isn't properly supported, because sometimes it's hard to get some of those pipe hangers in there, I know that. I've seen so many installations where they're trying to jam so much stuff into one room. You really want to have the support here so you don't have the weight of this water, the pipe, and these fittings pulling down and cracking the volute. So it's really important to have that support foot underneath that suction diffuser. We got our triple duty valve here. This is the angle variety. So pipe supports here, so that we're not transmitting, added strain or stress to the pump housing, so we don't have any issues with cracked volutes or anything like that. And then they got pressure gauges in here. I generally speaking like to see just one gauge. That way you don't have to worry about gauge plus or error or plus or minus of the gauge. They would essentially have the same error. So it's nice to have just one gauge. I know sometimes you end up putting a couple in there. It still works, but it gives you a little bit better accuracy with just the one gauge in there. So it's very important to put one on. On our pumps, there is a tapping on the suction flange as well as right at the discharge nozzle. You just remove the pipe plugs and you can put some pipe right into it and get your pressure gauge there. There's also some built in onto the suction diffuser as well, so you don't have to actually put T fittings in or a connection into the pipe. It's already built right into the pump. So some general startup notes. I have there's quite a, and of course you want to look at the IOM to make sure of the pump that you're working on to make sure you're covering all the bases and everything like that. Every pump is a little bit different, but this is just some general notes that I've come across over the years that I want to just kind of highlight a little bit. But the first thing the pump should be properly secured, leveled, and grounded. If it's not secure to the pump, I've seen a lot of pumps where they're base mounted pumps or motor mounted pumps that should be mounted to the pad. They're missing some of the bolts in there, or they're not bolted at all. What can end up happening is that pump, it does vibrate because it's moving, so you can actually see where the pump is actually bouncing on the pad. There was on some of the larger ones I've seen where they just put one in. Well, the pump is so big and heavy that it's not going to go anywhere. But what they've actually created was a tuning fork effect where the one end of the pump is actually bouncing up and down, causing more noise, wearing out couplers and stuff like that. So we want to make sure you're using all the bolt holes that you're supposed to be using, and that everything's nice and level, mounted. And then of course, you want the pump and a base mounted pump grouted. It's really actually important. There's only, I believe, one pump that B&G has. It's their large VSX pump that doesn't exactly have to be grouted. But it's important to do that because it just adds more mass, more rigidity to the base. You typically have less vibration issues with the pump if there is some that happens to be there. And it actually really does pull it away. I always, early in my career, I always thought that's what I got to say, and because that's what the IOM actually calls out for it. And it's like, well, I've seen so many pump installations that didn't have vibration problems until I actually ran into a pump installation that had a lot of vibration issues. Unfortunately, the pump was already picked on the end of its curve, and so when you operate on the extremes of the curve, you get pick up a lot more vibration. And this was so bad, you go into the main room, and this was in another room where the pump was located. It was probably about 40 feet away, and as you got closer, you could feel the whole floor vibrating. And I said, well, you know what? The pump's not grouted. It would get rid of some of the vibration. I'm like, I can't guarantee you get rid of all of it, but it'd get rid of some. So they said, okay, we'll do it. And they went ahead and did it. And now when I went back, you actually had to get right next to the pump to feel the vibration in the floor, where before you felt it as you walked into the room. So if you got a pump that's, especially a base mounted pump that's vibrating, it's a good idea to grout it. Again, you may not get rid of it because you could have other issues causing the vibration, but it certainly is not, it's going to help it and try to get rid of some of that vibration. One point on the inline pumps I wanted to make here. I see quite often there's some type of like clevis hanger or pipe hanger underneath the motor of an inline pump, especially like a Series 100 or a Series 60 where you got the bearing assembly there. You really don't want that to support the pump. The pump should be supported by the pipe. If you support it by the motor, you're going to misalign the pump, so the seal's going to leak. The bearing assembly or the bearings are going to go out sooner in the pump. I do understand why it's there, and I love to have it there. But what you want to do is make sure that you're able to freely swing that hanger underneath. So you don't want to actually support it, have it underneath, because it's when these things are installed in the air, because that's where they've been asked to install them. Or even if they're close to the ground, it's great to have that third hand sitting there, but you just don't want it to actually support the pump. So you want to be able to kind of swing the hanger beneath that motor, so you don't run into issues. I got a picture of where one was a little bit too tight, and the complaint was the pump was noisy. But yeah, you just want to make sure it's loose underneath it. That way, when you're pulling that motor out, you can rest it on that hanger. It's just, you're just talking, just a little bit, so you can just see some daylight between the motor bracket and the hanger. The other thing I saw touched a little bit earlier, closed coupled pumps, they should not be sprung in the piping. You should be able to pull the whole pump out, whether that's an inline pump or the base mounted or the in-suction pump. You should be able to pull them out, and where the volute doesn't move or anything like that, or the pipe doesn't move when it's being pulled out. Eventually it just adds too much stress to the pump, and something, eventually will crack. The volute, it's usually the volute, will end up cracking. So we want to make sure it's just not sprung in there. Base mounted pumps, you want to make sure they're aligned after they've been installed. They are factory aligned from the factory. It's really just to make sure that it can be aligned. But once it's being shipped, tossed around, and then installed, and you put it bolted down to a pad, it does get misaligned. B&G, about, I think it's been 2015, redesigned their new E-Series pumps. And some of this redesign was to get more efficiency out of the pumps. And so there's a lot tighter tolerances on these, and they also changed from bronze material on the impeller to stainless steel. Where that's important in alignment is that these tolerances are so tight anymore that you can turn a pump on, and next thing you know, it's noisy, it's loud, you hear the throbbing noise. When you had that brass impeller with these bigger tolerances, you would say, well, I'll just let it run in, and eventually the noise would go away. But with the new pumps, that stainless is a lot tougher than brass, so it doesn't really run in, but it's a kind of an indicator just by even hearing that the pump may not have been aligned. And of course, if there's still paint all the paints on the bolts, at least that the coupler guard. It certainly hasn't been aligned, but you want to make sure they're aligned. Like I said, I've had so many times since that redesign of the pumps that I've heard people complain about noisy pumps, and I said, "Did you align the pump?" "Yes, I did." And I go out, I look at it, and you can still see all the paint on the bolts. And in fact, I find it's off one way or the other, left or the right, or maybe it's too high or too low, and then align it up, and the noise has gone away. But the alignment, it also lengthens the bearing life, and not only the pump, but the motor, the coupler life, the seal life. You just want it completely in line with the motor and the pump. The EPDM couplers, those can be aligned with a straight edge at minimum. I know a lot of you guys use a laser alignment, which 10, 15 years ago, so they were very expensive. Not very many people used them. But now it seems like it's pretty well the common thing to do anymore, is to laser align the pumps. It makes it, I think I've seen it done. It seems to make it a lot easier because it tells exactly where to hit it and needs to be hit and where it needs to be moved around. But it's not exactly required for most of the couplers, except for the hydro coupler. That's that orange one. That one, the minimum that you can do with that is to dial indicate it. So you do it because the tolerances on those are so tight and so small that any little misalignment can just chew up that coupler. Some other notes, pumps may have to be lubricated. This is getting to be less and less anymore. A lot of the pumps are maintenance free, but we still got some of those booster pumps are the smaller booster pumps are still oil lubricated. So you want to make sure you put your oil in the bearing assembly, a few drops in the motor. But as you get to the larger pumps, a lot of them are sealed bearings, so you don't have to lubricate them. With 1510, you can still give it a couple shots of grease if you want to do that. For the most part, they should be pretty well lubricated from the factory, but if you want to give it a shot, you can. They used to actually, they found out that so many people would just put a bunch of grease in it. They used to send them out with a little bit light on the grease, but they don't really do that too much anymore. So you shouldn't have to really lubricate them too much. If it's noisy, you can give it a couple shots of grease. It's probably been about 8 years ago, they did change their grease in their pumps. The 1510s used to have that, use the lithium #2 grease. And of course, you don't want to mix the greases between that and Polyrex was the other common ones that a lot of the motor manufacturers use. But about 8 years ago or so, they changed the grease that they use in the 1510s from the lithium #2 to the Polyrex. So you do want to be careful which grease you're kind of putting in there, because the two evidently shouldn't be mixed together. I guess one pushes kind of the other one away, and all of a sudden it's under greased, and you have all kinds of problems with the pump. But they did change it. In fact, if you buy just bearings today, they used to come pre-lubricated, but they're now not lubricated just because some people still might be using the lithium #2. This comment here about enough system resistance to keep the pumps from overloading. It's really from a new pump installation standpoint. Some of these that you need to provide temporary heat. So and the system's only partly on, it's just these units, it's not the whole system. So sometimes in these new systems, there's very little resistance. So when you turn them up, the pump goes all the way to the right of the curve, off the curve, and now it's vibrating like crazy, making all kinds of noises. But hopefully, if you got like a triple duty or balance valve, you can throttle that down, maybe turn it down to about 50% before you even turn the pump on, just to make sure there's enough resistance so that the pump just doesn't run off the curve. But so you kind of want to watch out for that, especially on newer systems. The old ones, or where you're just doing a pump replacement, you really shouldn't have to worry about that because it's already been balanced. You just open the valve up back to where it was before and go ahead and turn the pump on. But before you turn the pump on, you do want to make sure you verify your incoming motor and the power connections. Three-phase, you do want to make sure you're turning the pump the right way. There is an arrow on the pump of what direction it should be spinning. You can kind of push that to where look at where the motor should be spinning. So you want to make sure it's going the right way. I've run into a few instances where it was running the wrong way. The pump will actually pump running the wrong way. The flow that it's going to put out is significantly less. So you're going to have a lot of flow issues, but it may actually pump, maybe if the pump is supposed to do say 300, it might actually put 25 or 30 GPM out there, but you'll certainly have a lot of flow issues if it's running backwards, but it may actually provide the right pressure that you need to. You want to make sure that it's wired up properly. You got your 460 wired for 460, or if you got 230 wired for 230. Some of the pumps that they used to have when they were on the motors, it was kind of tough to figure out what the wiring was, and I've seen couplers break because it's not wired properly, or the motor spins too slow because you got, it's wired on high voltage and you got low voltage coming in. So you want to make sure, just to kind of double check to make sure it's wired properly before you turn that on. Some of the tools I like to go out when I'm trying to troubleshoot a pump where I'm having some issues with it. Certainly the pump curve is a great thing to have. You always want to have that with you. There is an app that B&G has. It's I think if you search for B&G, it's their I can't remember what it's called, but it has it's pretty easy to use, but it's just an app that has all their parts listing, all their curves, submittals. It's just there. It has all the data that you can get on the website through the app, and in some cases it's a little bit easier to use. You can search for the pump and it pulls the pump up, so you can at least kind of pull up a pump curve, or maybe the breakout of the pump on your phone, on your smartphone there. So that's available for you to have if you don't happen to bring it. There is an online selection software system-wise where you can actually put the flow and head in, and it will generate the actual impeller curve that you might have for some of the larger pumps. Again, we'll get into that here in a little bit. But yeah, you can put the flow and head that you have of the pump, and then if you can make an adjustment to the impeller if you don't have the right impeller diameter that it picks for you. Of course, the PSI, the foot of head conversion, again, because the pump curves are in feet of head and all the gauges are in PSI. Having a good ammeter is nice because that way we can check the amp draw that the motor has. An adjustable wrench seems kind of interesting. You want an adjustable wrench, but the triple duty valves and the circuit setters aren't, they're not. Once you get past the smaller ones, they all have a flat to them, or a square in case of the triple duty valves and big circuit setters. And the only way to really use to open and close those is with an adjustable wrench. So it's good to have a pretty good sized wrench around. Sometimes they're hard to open and close. And then to kind of remember these two formulas, where the BTU divided by 10,000, assuming a 20-degree delta T, tons times 3 for a GPM if you've got a cooling system. Again, it's really just to get an idea of the flow that you might need out of the pump, because a lot of times we find out, pump tags are gone and we're trying to figure out what this pump is trying to do or what it should be doing. So we'll go run through some of these pump curves. This is just the booster pump curve. They're all somewhat very similar. But however, a little bit different once you get to the larger ones as far as the information on the pump curves. This one here, pretty simplistic on the booster pump curves. You got your model numbers. There's a PD40 down to an LD3, a 2-inch booster, Series 100. But basically, each pump is one pump curve. And then you got your flow. It's almost always on. Most of them are always on the bottom down here in GPM. And then you got your pump head on along the side up here. You got multi-speed curves here. So it's very similar as far as basically you got a model and speed on it. You know, we've got 3 different models, the NRF 25, the 36, and the 45. You got 3 different speeds that you can dial in for these pumps. And they're just, I'm sorry, you got still the pump flow and head shown on the bottom and the side. Now you got these, I don't know if you can see it, but they're kind of color coded. You got red or a burgundy color for these, for the this number 6 there. So it's the NRF 36. The green is the NRF 35. And this blue is the NRF 25. So depending on what speed setting you have and what pump you have is what curve you're actually going to read for this one. And then these curves are kind of interesting. These are our ECM pump curves. You can see this one's like got a control of a proportional control to it. So the pump curve looks a little wild where it's kind of coming up and going down. This one's a constant pressure, so it's going out to the edge of the, if it's pump curve. This one's a constant speed, so wherever it's on the dial setting, that's the pump curve it has. Some of the issue with these, it becomes a little bit difficult to figure out where you're operating, especially with like these two here, because it's tough to know where they're actually at on that curve. For us, like this curve 6 here, you could be at 0, or you know, you come out to looks like about 8 GPM, depending on what the system's allowed to do. So it becomes a little bit hard to troubleshoot. And you get to the bigger ones, and like these can operate anywhere in these shaded areas. So this like 4275 can operate from out here all the way down to here, depending on, you know, what speed it's running and all kinds of stuff. So it becomes a little difficult to troubleshoot these pumps with the ECM motors, but they are becoming more prevalent. The energy that these use is somewhere between 1/4 to half of what like an equivalent motor might use on some of the booster pumps, the small like 100 and the HV. This one here is the multi-speed curve or multi-stage curve. So that was the pump that had it looked like it had a big stainless steel section in between it, with the motor on the top and the cast iron housing. These things can be quite tall because it basically just keeps stacking impellers on top of one another. But this is very similar though. So this up here in the corner, you got your model number, and this has got your speed up here as well. And you got your pump flow and head in the same locations. And what you got here is these are the different impellers or stages. So this one could start with 2 and go all the way up to 30. So it depends on how many impellers you have inside. It dictates which curve that you're going to use. And down here this is your horsepower curve. Now this is the horsepower per stage. So if you got, you know, a 10 stage, it's basically 10 times wherever you're trying to operate. So if you're trying to get to, you know, this is 8 GPM, you kind of go up to this line. The horsepower reading is over here, so it hits it right at 8. You come over, it's 0.10 horsepower per stage, so that roughly uses about 1 horsepower for that 10-stage pump. Your efficiency curve is down here. Again, this is just a straight efficiency of that pump. It's located on this side over here. And this is your net positive suction head. We touched on a little bit earlier. We talked about open systems and closed systems, but you can see here, this curve is pretty low at the beginning where you got a lower flow, and as it starts to jump up here towards the end, if you're trying to get out towards, you know, this side of the curve, you can see if you run back over here, you might need 20 feet of pressure for that pump to work properly. So on those open systems, you got to be careful where you're operating, so you're not having so much pressure at the pump suction for it to work. Like I said, you know, you could get into a cavitation issue. Of course, that would end up destroying the pump. It'd certainly be a lot, you know, pretty noisy and everything like that. Here's a pretty typical centrifugal pump curve. This is pretty current curve for this. A little more information than what they used to have in years past. We'll go over that, of course. The first thing we see is this is the pump model located up here. You know, the 1510 or the E1510. We got size, max impeller revision. Used to be that this like A and the B's and the C's, this first letter here meant a lot to a lot of the manufacturers. The A would be a 7-inch impeller. The B would be 9.5. C, I believe, was 10. You get up to E, I believe that's 11. But every manufacturer used to do it this way. Now most of them have gone to like a, like in this case, would be a 2.5 by 3 by 7. So they actually list out the discharge nozzle, the suction nozzle, and the max impeller. C is going to be your revision. So this is going to be the third revision of this pump since it's been introduced. Pump flow and head in the same locations as the other ones. So this here is your impeller size. So, you know, this one's going to have anywhere between a 5-inch and a 7-inch impeller inside of it. So it makes a little bit, if you don't know what the impeller size is from the pump tag, could be hard to tell like where you're actually running. So you wanted to try to somehow determine what impeller size you have inside the pump. These light lines coming across here are your impeller curves, or your horsepower curves. So anywhere where you choose a pump, it needs to make sure that you have at least that horsepower on there. So like here, if we're looking at 200 and we're going up to 25, 25 feet ahead. So we're right here. We can't use a 1.5 because it actually uses more than 1.5 horsepower. So we need to use a 2 horsepower motor on that pump. Now, one thing I do want to point out, like if we were back here and we had like this 6.5-inch impeller on here, and you can see this 2 horsepower line crosses that the 6.5-inch curve, you can actually use a 2 horsepower motor on there, but you're going to need to make sure that that flow is going to be, you know, roughly, this is roughly under 150 GPM, because the pump is, or the duty point could ride anywhere on this curve. As you approach this horsepower line, is like at this point right here, where this little cursor is at, you're going to start to overload the motor as you ride on this, what they call riding the pump curve. And it's depending on what your system pressure or requirements are. And so you could start to ride over here and you actually use more than 2 horsepower, so you're going to start to overload the motor. So what a lot of people do is, if you're using like this 6.5-inch impeller, they want a non-overloading motor throughout the pump curve, and so they'll jump it up to 3 horsepower. So that way, if you actually are running out here, or maybe you want to run back here and you start the pump up and it actually is running out in this direction, that you're not going to have issues with the motor overloading. So these little half moon or arcs, this is the efficiency curves. You do want to try to be at the best efficiency point. Is the best place to operate, because it's where the pump is most efficient. It's also the point where the pump is vibrating the least. The further you get out to this direction and the further you go out to this direction, the pump will vibrate more. So if you could kind of stay in the best efficiency point area, it's going to reduce that likelihood of that happening. And the pump, I'd say, that was vibrating really bad, it was operating way out to the end here. And unfortunately, it was the only pump that, for the condition that they had, that we had to get it at that point. It was the only pump that could have been picked. But it was operating out here, so it was vibrating pretty bad. So they grabbed the pump, it helped it out, but it still vibrated. It's just because that's where it was operating at. And this is your net positive suction head curve. It's a little bit easier to see on this one. It's a little bit bigger, but out here's your scale for it. You can see, you know, if it's a cooling tower application, you're at 200 here. You kind of come over. You know, it's only 5 feet that you need, which is going to be about 2 pounds of suction pressure, which isn't too terribly much. But if you're all of a sudden start to need to operate out at this end, now you need 10, or maybe, you need almost, 15. And so you could need a lot for this thing to work. So you might, if that's going to be too much, not enough, if you're not going to have enough for this pump, you might want to pick another one where you're kind of operating back over here to where the suction requirement is a little bit less. This little box up here, this is something new. This just started to take an effect in January of last year, January 2020. It's a what they call the pump efficiency rating. The PEI is pump efficiency index, and the ER is the efficiency rating. There are actually two different ratings. One, the Department of Energy is the PEI, the pump efficiency index. Basically, they came in and wrote some legislation and saying that any pump has to have efficiency rating less than 1 for it to be sold. So if it's anything, if it's above a 1, it cannot be sold. If it's below 1, you're okay. So for this pump here, where it says pump and motor, it's 0.91, so that's less than 1. So it's good to sell. But this efficiency rating also can take an effect of a motor and drive. A lot of times with these pumps, we can sell a drive with the pump, and so it's going to be paired with it. So you can see this efficiency rating actually looks like it goes down, where in fact the closer to 0 you are, the more efficient it's going to be. The higher the number, the less efficient. So you can see this 0.5 is quite a bit more efficient by just putting a VFD on this pump than the 0.91 with no VFD. The ER comes from the Hydronic Institute, and that one's the opposite. So the higher the number, the more efficient it's going to be. And I'm not sure the whole equation part of it, but it has to do with where you're running the pump. It has to do with part loading the pump, and where it's operating, where it's suspected to operate, and everything like that. So that's something that's been new that just came out, and that affects most of the centrifugal pumps from 1510s to Series 80 inline pumps, larger base mounted double suction pumps, anything like even turbine pumps have to be rated with this as well.
Are we getting close to the to that last question, Eric?
Not quite. A little bit. We got a little way to go, I guess. Getting there.
We only have 5 more minutes, so can we?
Oh, gotcha. Yeah, we can get there. So the operating range of this pump, this is the ASHRAE operating range. It's basically 85% to 105%. So you want to this pump should be selected in that area. The acceptable range is this one here. It's a little bit larger, 66 to 115. The HI, Hydronic Institute, is kind of this gray area here. And then we'll get to the question here. But I guess I do want to point real quick on this pump performance here. This is the wordy portion of it. Basically, you're taking a reading between the suction and discharge pressure, convert it to feet, and we're going to go ahead and plot it on the curve and read the GPM from it. So a little graphic here. We've got a suction reading of 20, a discharge reading of 33. Convert that over. Do the math there. 33 minus 20. Convert it to feet. So we got a 30-foot differential. So we take our curve for this pump. It was supposed to be 20 and 35, so we're not getting to 30 feet. We actually have, we're not getting to 35. We actually have a little bit less. So we're going to plot the 30 right there on our pump curve and go down. And we see we're doing about 230 GPM or so. The way to get that back is to close that triple duty valve or balance valve. So we actually draw that back and add pressure so we get back to our point where we want to operate at. What I did want to also point out, you can do a no-flow head test to see what impeller. Sometimes you don't know what it is, but if you close the discharge valve for a little bit long enough to get your readings, you can actually kind of estimate what that impeller size would be. So if we close that discharge all the way down, now we know it's a 0 flow, and we come back up on the curve, back up to here where zero flow is at. So your differential should be about 43, 44 feet or 20-pound differential. So you can kind of estimate what that impeller size can be at that point. It's not exactly accurate, but it's close enough to kind of get you an idea. This is just kind of troubleshooting vibration and the full amperage. You're over amping. Here's a nice little picture of a cavitated impeller where you can get like some air in the system or low suction pressure. Another common thing we see is coupler breaking. So you can see it's kind of worn out down here. So you just want to change those motor mounts. And here's a picture of the picture I said about where the pump was being supported. You can slightly see where there's a little bulge down here where it's actually supporting it. And if you just lower this down a little bit where it's not touching, would be perfectly fine. Some of the things like bearings are allowed. Sometimes they just need to be greased, but misalignment certainly can cause that, or if it's running towards the extremes of the curves, can cause those issues as well. Seal leak is, always try to caution people not just to throw away the seal if you have problems with the seal. Leaking a seal that's kind of failed, it kind of can tell a story. So we got like this one here, it's dirty water, where you can see like grooves are cut into here, like the old vinyl record players, which are, I guess, making a comeback these days. This one's got a little bit better picture on the rotating face here, where you can see these little lines in here of it. And we got unseated seals where there are misalignment, where one side of this rotating, I've seen this where this one side was completely worn down, the other side looked brand new. This is what a seal looks like when it's been ran dry. It will have cracks radiating out, or you'll see blistering on the face. So sometimes it tells the story, of what happens to these seals, and you just don't always want to just immediately throw them away. Glycol seals, we see them leak initially sometimes, but there is an upgraded seal. If there's too much glycol, usually it's like above 35%. I start to think about putting them in if you're having a lot of leaky issues. It used to be they leaked initially, but now everyone pretty much uses the premixed stuff, so you don't have those kind of issues. Replace the pumps. This is kind of some of the information that we asked for. This is what a nameplate looks like. You don't, I've never seen one before because I know a lot of times they get torn off, but this is on our Series 60 and larger. It's a nice little metal nameplate. Gives you all the information on the pump, including this is the serial number right here. Flow and head conditions, the model number, the impeller cut are all on there. Smaller pumps put a sticker on the bearing assembly, which has been changed out since you got to it, I'm sure. So I'll give you a little bit of information that you can look. You can see these stickers. These are the PEI and the ER ratings of the pumps at the Hydraulic Institute. B&G puts on all of them. Again, the pump efficiency index has to be less than 1 in order for the pump to be sold. But it's basically like almost like an Energy Star type sticker, where you can kind of compare the pumps to one another. Some of the motor information that we might ask for if you don't have the name tag, horsepower, speed, frame size. There is a B&G part number that we can cross over to our pumps, or cross over to some of the booster pumps. Might ask what type of pump that you might have. Casting numbers are also all very helpful. You can kind of see on here, this is P85923. This will correspond to at least the size and type of pump that it is, to that pump model. There's also one on the motor bracket. You can kind of see it here. I can't quite read it in this picture here, but at least again, it's an idea of what family of pump, or what model of pump that you have. If you don't have that, sometimes you can ask for we can find out the flange size and number of bolt holes on there to get an idea of what the flange will be. We got the impeller size. if all else fails, there's been a couple times where we've kind of gone back and re-engineered the system, and we asked those questions to kind of just almost redesign the system by itself, to say, okay, this pump will work. Because some of those have no information whatsoever on it, so we'll kind of like take some guesstimates and use the boiler rate or the chiller rating to kind of come up with a flow, and of course, last the length of the loops and stuff like that to get a pressure reading. So in and outlet pressures, pipe sizes, again, some of this stuff is just an idea to get where we need to go to pick a pump or to verify this is the right size pump that we got. So here's the final question here. What is the pump efficiency index that qualifying pumps need to meet? And the answer is less than 1.
Okay, guys, there it is. Number 3. What is the pump efficiency index, the PEI, that qualifying centrifugal pumps need to meet? The answer is less than 1. You're going to have to type that in. Okay. Are we good to wrap up here?
Yeah, that's the end of it. There's a couple of apps that B&G has. The mobile catalog, that was the one where you can get a link to all their curves and everything like that. IOMs, parts listings, system size. It's a nice little tool on the app. There's another app for that as well. You can use that going out in the field there to kind of use it for circuit setters and stuff like that. So
Okay,
they've
great.
also updated the training and education page. You can even earn credits there as well, potentially. That's on their training site.
Okay. Well, here, guys, I said we were probably going to run short, and it looks like we could have gone another half an hour. So my apologies there. I did send an email to everybody just now. The answer page is open, so you're off to the races. Thanks, guys, for joining us today. There's somebody named Fred logged on. I have no idea who you are. I've been trying to get you to give me your last name for the last 2 hours, but I haven't heard back from you. So if you need, I don't know if I sent you an email or not because I don't know who you are. Okay. The rest of you guys have a good night. Thanks again. And this is our last class of the year. Don't forget, next week we have our luncheons, one in Spring Grove, Hamilton, and of course, Tri-County. That's on Wednesday, Thursday, and Friday. Be sure to join us. It's always fun, and we haven't been able to do it for a couple of years, so this is going to be especially fun. All right. Thanks for joining us. We'll see you all. Merry Christmas to you.
Thanks, guys. Appreciate it.
Bye-bye.
Larry,
Yeah.
I didn't get question 1. Is it only 3 questions with this one?
Yes, there's only 3 questions.
I didn't get question 1.
That's because you signed on about an hour late for class.
I thought I was only like about 30 minutes late. I signed on at 5.
5?
Yes.
All right. Can you get to your email?
Yes.
All right. I'll send you something in your email.
Okay, thank you.
All right. Okay.
All right.
Bye.
All right.
Hey, Larry.
Yeah.
This is Jeff Flynn. Did I just submitted mine? Did it come through? Because I was having trouble with my email.
I have no way of knowing, Jeff, until I look in there tomorrow.
Okay,
Uh,
buddy.
But I'm getting a ton of them, so I'm sure you're in there. But I'll make
Okay.
a note of it. If I haven't, I'll reach out to you tomorrow.
Thanks, Larry. Have a good night.
Have a good night.
Goodbye.
Bye.
Is there any way you can resend that to me? The email?
Who is that? Mike?
This is Mike. Yeah.
What do you need? Oh, the link?
Yeah,
You
I
need
need that link. I can't get on.
You didn't get it from me just now?
No, I didn't get it. I didn't
Let me
get it.
Let me look. Is it your fuse.net email?
Yeah. Just resend it and I'll go in and get it.
Yeah, I'm gonna do that right. Whoops, that's not it. Hang on, I'm gonna do it right now. Yeah, fuse.net isn't gonna block it. Okay. Well, hang on just a second. Are you in your email now?
No, I got to get back into it. I don't know how to do that at the same time.
Okay. Okay. I'm sending
I'm
you.
not very computer savvy.
Yeah, that's all right. Well, while I've got you, okay, I've just sent it to you. So,
Okay.
then,
I'll be back if I don't get it.
all right.